answering that question.
Yeah.
It is. Good question. You can also have written this as 1/3 y plus 2/3 equals x. Either one of those would be right. So, someone asked that. It is a function y.
Because there's not double
Passes.
Passes the vertical line test. The x's don't repeat. All of those things sound wonderful to me. So yes, this is it. Find the composition of those two functions. So this is a little bit of practice from the last 2 days. F of g of x, which is f of x plus 2 divided by 3. So how do you do that? Put that in for x into the f function. I do 3 blank minus 2. Where that blank is, I'm going to put x plus 2 over 3. Any questions so far? We're going to simplify it. How do you deal with the 3 times x plus 2 divided by 3?
You take
What do you mean?
like reverse.
You could split the bottom and multiply. Let me say that again. Everyone listen to this. Y'all listening? 3 times x plus 2 divided by 3.
Threes could cancel.
Doesn't that feel like those 3's are going to cancel?
Right.
I'm multiplying by 3 and then immediately dividing by 3. Aren't those completely opposite things?
Just like cancel each other out. The threes.
Doesn't it seem like those functions did the complete opposite thing? One multiplied by 3 and subtracted 2, and one added 2 and then divided by 3? Those are called inverse functions, and that's what we're going to be looking at today. Inverse functions undo each other. An inverse relation or an inverse function is one where the domain and range values are switched. So you take all the x's, all the y's, and switch them. The graph of an inverse in the original is a reflection of the line y equals x. And remember, for a function to be a function, you must pass the vertical line test. Well, for switching to x's and y's, on the original function, the y's would have to not repeat also. We'll talk about that on the next slide. I'll give you some time to write. Okay, so find the inverse of the function is the inverse of function. So we're going to look at inverses with points, we're going to look at inverses on graphs, and we're going to look at inverses with functions. With points, it's really easy to find an inverse. What do you do? On the first slide, what did it say? Or last slide, what did it say to find an inverse? Switch to x1. So instead of 2 3, 3, 4, and 5, 4, the inverse is 3, 2, 4, 3, and 4, 5. So, well, but 3 and 2 have to sit together. Yes. You just switch all the x's and y's around. Is the inverse on this one a function?
No.
Why not? The 4s. Was the first one a function? First one was, but this one's not. So you do the next one. Find inverse. First of all, is this next one a function?
Yeah.
It is. How'd you do that without switching it? The y's don't repeat, right? So you can tell it.
have to write that down. Can't we just like look like
Well, you could. Now, it did ask to find inverse. But if it didn't ask that question, you could just look and see if the y's repeat. No, the domain and the range of the function and the domain and range of the inverse, they switch. X and Y switch. Okay. The definition that Hunter just said earlier, when she said, hey, if the y's don't repeat, then the inverse is going to be a function. The math words behind that sounds yucky. But a function from A to B is called one-to-one if whenever f of A equals f of B, then A equals B. What that means is the x's don't repeat and the y's don't repeat. If neither the x's nor the y's repeat, then you have what's called a one-to-one function. You can test to see if a function is one-to-one by doing the horizontal line test. Why do you think you could use the horizontal line test? Because it switched around, it's the y. So the horizontal line test tests to see if a function will have an inverse that is also a function. Now everything has an inverse. We can always switch x and y. The inverse just may not be a function. If a function is one-to-one, then the inverse is also a function. So see if you can answer those questions. Are those functions one-to-one? Okay, let's look at the first one. One-to-one or not? No, why not? It touches, the horizontal line touches at more than one place. So if we were to switch the x's and y's, the vertical line would touch at more than one place. So this function is not one-to-one. What about that one? Yes, no matter where I go on that line, it does pass the horizontal line test. Yes, it looks like it might not right there, but it never actually. Now, some cubics would be a no if they actually dip back down. This one just kind of stalls out and goes back up. So, yes. Last one. No. Any questions about that? Okay. How to find an inverse function. Write these steps down. Okay, while y'all are working, I have a little bit to say about homework. Of course, we all have homework as a book page. It's on my next slide. I also have an optional assignment for you. Originally, today was a quiz day, but we lost like 2 days in there, so I scrapped the quiz, but I homework bonus assignment. If you do it over the break, we'll grade it Monday morning. If you do it, it's a 10 bonus. So it's like if you have not done the homework, you get bonus points. So this is a bonus assignment. It's what would have been the quiz. I'm going to hand it out to everyone, but you don't have to do it. It's bonus. Okay?
I realize
Yes.
no wonder great.
So this assignment, this quiz is a 10-point bonus assignment. If you want to do it, you can. If you don't, I would say, as you know, these quizzes are good practice for tests. So bad idea. I just decided I was going to do it. Okay, so step one, to find an inverse. Rewrite f of x as y. It makes it easier to see how to switch x and y. So step one, rewrite f of x as y. Switch the x and y. So that's step two. So instead of y equals 3x, I'm going to have x equals 3y minus 2. Solve for y. So you see why on the bell ringer I made you solve for that x earlier? Practice. Solve for y. How will we solve for y? Add 2. Divide by 3. And rewrite y as f inverse. So just rename this as f inverse of x. The little negative one at the top stands for inverse. So that's f inverse of x. Would you agree that these functions seem to undo each other? They're the ones from the bell ringer that we did the composition of functions and just got x because everything seemed to cancel. The graph the function and its inverse will be a reflection of the line y equals x. You can use this to check your work. You can graph them both, and I'm going to do that on this one. F inverse is x plus 2 divided by 3, or if you wanted to rewrite that as a line, it's 1/3 x plus 2/3. Rise 1/3. Graph it in your calculator. So that is the inverse. Do that. Yeah, into 2/3. The y-intercept. I just rewrote y as f inverse. So it's x plus 2 over 3. I just called it a different name. I just called y. It's really just a rename. You're just renaming it because we found the inverse and we're saying, hey, this is the inverse. So this is the mathematical way to say, hey, this is the inverse. No, it's called a field. So this is the inverse. 3x minus 2. What you will notice is that these two functions are a reflection
Oh,
No, so what does that mean for inverse? The inverse is not a function, right? And if you start just for fun, we wouldn't have to do this, but if I started just switching x's and y's on the graph, 0, 2, 2, 0 would be on the inverse screen. 1, 3, so 3, 1. Negative 1, 3. So 3, negative 1. Isn't it a parabola that looks like that? Which is not a function. So that's something to kind of keep in mind as we're working this. So, y equals x squared plus 2. What's step 1 in finding an inverse? Okay, they did that for us. Rewrite f of x as y, done. Step 2, switch x and y. Solve for y. What's the first thing? Subtract 2. And then what? What happens when you square root?
Plus or minus.
And then normally I would rewrite as f inverse. On this one, since it's not a function, if you don't, that's okay. Right. No, because x minus 2, so it's not negative 2. It's just x minus 2. So I don't know what x is. Is the inverse a function? Is the function 1 to 1? No. Is the inverse a function? No.
okay.
We all
You will read the test. You're only going to take one slide.
Like it.
We got a lot of ones.
But you have both. That's why you get the top graph. And where are we going? Okay, one other piece of information that's nice to know, you saw this in the bell ringer. If you have two functions that are inverses and you do a composition of two inverse functions, you get x. So if you do a composition of functions with two inverses, you just get x. Why? From the bell ringer, why does that happen? Don't they end up undoing each other? Everything cancels each other out. So mental note, you compose two inverse functions, you get. I'm going to do one more table if I have time. This is your homework. 2 through 24, you get 12 problems. I think you will be okay. I would recommend doing this tonight, because if you don't, then wait till Sunday night, you may truly forget how to do this. So then you may just have to watch the video and do it. I would just do it tonight. And then the sequence is optional. It is 10 bonus points. Did you get a copy of that? It is optional and 10 bonus points. Take homework is not optional. And where do you go?
I wrote that.
That's what teaching.
Oh, sorry.
Got 5 more. Okay, do one more. One more example. This is another weird example. Finding an inverse function of the square root of x plus 3. You can graph that in your calculator. It's not a bad idea to start by graphing it in your calculator, just so you kind of know what you're getting yourself into. So this is a tough one. I don't know if there are any this tough on your homework or not, but this one's a weird one. Okay, the inverse should be a function. Does everyone agree? Because that is definitely 1 to 1. Okay, let's find the inverse. Okay, step 1, rewrite f of x as y. Then what? Switch x and y. minus 3 squared equals y, or f inverse is x minus 3 parentheses squared. But I have a problem. If I graph x minus 3 parentheses squared, what does it look like?
I mean,
3, 0. So wouldn't it be a parabola that looks like this? Someone tell me why that's a problem. That's not the inverse of that, is it? It's got too much stuff, doesn't it? Well, which part of it really is the inverse? Let's look. 0, 3, 1, 4. So 4, 1. Not this left-hand piece, right? So it should only be this piece. Right? So I want to say that in my answer. I want to say only the piece to the right. Because we got extra stuff. What made that happen was that this one is not 1 to 1, right? And so that causes a slight problem. You start with a square root. That will happen every time you have to, what's called restricting a domain. That's a weird one. They don't